Hello everyone, this is Mr. Chang, and this is the last lesson for this unit, lesson 6 on rational exponents part 2. So first we have this summary here. You should know all of this rule. They are not given in the test, so you should know them. So these are the old one you should all know. Now what new this year is the last two. When you have an integral exponent, this means 1 over xm. And then when you have a rational exponent, it means the xm to the nth root. You can also take the nth root first and then before you bring it to the power of m. Okay, so those are the rule. And let's look at some example just to get ourselves familiar with the rules here. Example number 1. Write each power as a radical. Sure, so write as a radical. This is 6 powers of x. Now the difference between B and C is this one have no bracket, this one have bracket. So with the bracket, the cube root is included there. Okay, and then you can put a 5 in here or out there. Doesn't matter. Let's put it outside. Let's put it on the outside. The final value of this, because you cube root of a negative number is negative, negative to power 5 is still negative. So the overall expression C will be a negative number. And then for B, the difference is the negative is on the outside. You're only taking the fourth root of y and then you cube it. Like you bring it to power 5. You can't take the fourth root of a negative number. So this negative is on the outside. Here, first, for D, you have a negative exponent. So first you flip it. Don't forget the bracket. And then you just rewrite everything. The question asks you to write as a radical. So you can just write like that. And then for part E, the exponent only applied to the t, not to the 5. So the 5 just stay there. You cube root t4. The 4 can put inside or outside, doesn't matter. It doesn't change the value. However, for f, the difference is there's a bracket. So all 5t is inside your cube root. So that makes a huge difference. You can either write the t on the outside, 4 on the outside. If you write inside, you need a bracket. If you don't write the 4, right? If you don't write the bracket, then it looks like it's just 5t to the power 4. Then you miss the 5, right? The 4 also apply. The 4 exponent also apply to the 5 as well. Okay, so that's the answer. For example number 2, simplify the following and write each expression as power with positive exponent. And then write them as entire radical. So let's write them as exponent first. So when you multiply them, you add the exponent. You don't see it, which means it's a 1. So 3 over 2 plus 1. Well, how do you add exponent? You need common denominator. So I'll make this 2 over 2, right? Because 1 is same as 2 over 2. Common denominator. Why did I make a 2? Because you have a 2 here. So now add the exponent. 3 over 2 plus 2 over 2 is 5 over 2. This is how you add fractions. The denominator stays the same, you add the numerator. And now that means square root of x, put a 5 there. Okay, so first you write that as a positive exponent, next you write it as an entire radical. Next one, you divide, which means you minus them. Subtract the exponent. They are both have the same denominator, that's good. So this minus that, there's a negative 4 over 3. All right, write them as a positive exponent. Then you have put it in 1 over 4 over 3. Now write that as a radical. Okay, y4 cube root. C, power on power, you multiply them. Just multiply them. You don't need common denominator. So 1 times 2, 1 times 2, 2 times 3, right? So that's 2 over 6. This reduces to 1 over 3. When you multiply fractions, you can also cancel out the numerator and the denominator is also 1 over 3. Cube root of A. All right, finally, this one, let's deal with the negative sign. You know it. Flip it. And then half. And then we'll write as a positive exponent, so you can apply it inside. Y half. X2 times half is 1, so just write an x there. So that's the first answer. Second answer, write that as a radical. Here we go. Okay, next example. So this lesson, you can see nothing new, right? It's just working on rational expression, just do a little bit more. They split into two lessons, so you can take your time to learn it. Example number 3. So mixing different things, right? Numbers, positive, rational, exponent, negative. So what do? You need to do the negative first, right? So that becomes 4x 3 over 4. Well, you can subtract the exponent too. So let's do it this differently. Okay, so what do you do here? When you multiply the number, which is a 12. When you multiply the powers, you add the exponent. So 3 over 4 plus negative 1 over 2. To add them, you need common denominator. Let's change that to negative 2 over 4, right? Common denominator with a 4. 3 over 4 plus negative 2 over 4 is 1 over 4. X 1 over 4. Write each expression as the positive exponent. Here we go. And then write as an entire radical. So that's the answer. And then we move on to 4th root of x. Next, same thing. All right. So there's no brackets here. So then 5 and 25 cancel out, leaving a 5 in the bottom. The power and power, you subtract them. So 3 over 5 minus negative 3 over 5. Minus negative is plus. 3 over 5 plus 3 over 5. That's 6 over 5. So the answer is x 6 over 5. Where do I put the 5? The 5 is in the bottom. It stay in the bottom. See, this is the bottom. It stay in the bottom. It has no reason why it suddenly popped to the top. And then now you write this as your final answer as radical, which means you need a radical sign. All right, finally, part C. All right, you power on power. This apply to both of them. Okay, a to the power 4, 3, right? A to the power of 1 half times 4 over 3. The 2 and 4 cancel, leaving a 2. So that's 2 over 3. All right, so what's 8? So what is this? Well, let's take a cube root of that, and then fourth, right? Cube root of 8 is 2, 2 to the power 4 is 16. So the answer is 16a 2 over 3. Write that as radical cube root of a squared. All right? So that is example 3. Let's see more example. What are other varieties? Writing radicals as power. So we see this form. We saw this before. We see this form. Nothing new. All right, let's keep going. Write radical in form of an. Oh, okay, so just going backwards. So given radical, this is a5 over 3. Remember the root is your denominator. Here, a2 over 5. Here, a9 over 2. Square root is a 2. Here is in the bottom. All right, they want it in this form. They only want the a on top. So this one, you can write that as a over a7 over 2 and flip it back to the top, become negative 2 over 7. Okay, remember the negative is reciprocal. Write as a power and then evaluate. Wow, look at that. So interesting. Square root, square root. Square root mean 1 half. So this become square root of 129 1 half, isn't it? Right? Square root become 1 half. And then this square root is another 1 half. So this is 1 half of a 1 half. Okay, so there's another 1 half here. This is power on power. The answer is a quarter. And then evaluate. So you can put it in a calculator. Take a fourth root. This is the same as having a fourth root of the 1296. You can put that in a calculator, see what does that equal to. This one, all right, this means write as power, right? Half, square root is a half. We know square root of 169 is 13. So that's it. That's the answer. It stays in the bottom. It doesn't change to the top. Okay. You can write in the previous step, you can write like that, negative half, but it still give you 1 over 13. Same. Finally, what do we do here? Well, you turn the inside to a half, right? Next, you turn the outside to a quarter. 1 sixth. So power and power, you multiply them. A 6 root. All right. 6 root of 64, which is a 2. 6 root of 64. That's why they choose 64. You can see the shortcut. You can say if you have root, radical, and radical, you can multiply the index here, become 6 roots, right? 6 root is the same as 6 roots here. Here, 2, 2, same as having a fourth root. Okay, but you don't need to use that shortcut. You can just always write that back, like use a rational exponent to express the expression. All right, example number 6. Write each expression in the form of AXN. All right, here you can separate it, right? Cube root of 8, cube root of x5. They always pick the number that will work. So cube root of 8 is a 2. And then x 5 over 3. That's what they want. They want a coefficient a in the front and then x to the power of n. N could be rational number, so it could be negative 2. All right? Next one. Fifth root of 32 is a 2. 2x 3 over 5. Next one. Square root of 900. You can separate them. Okay, that's 30. X half. Next one. Oh, what do we do? Okay, this one is this. This one is this, right? You turn that into a power. Now you're multiplying, then you add the exponent. You add them. 5 over 3 plus 1 over 3 is 6 over 3, which is, oh, just an x squared. Finally here, what do we do? Okay, 2x and a half times x and a 1/3. Okay, you need common denominator. So make it into 6. There's a 3 here. You make this into a 6. It's a 2 here. All right. So you have 2x, now 5 over 6. All right. So that's the form they want. Good. We did the homework. Well, no, well, we did the exercise. Any more? Okay, last page. All right, we're almost done. Evaluate the expression using exponent. Write an equivalent expression using exponent. Sure. Didn't we do something similar? Okay. The inside become 3 over 2. All right. And then the outside become another half. So a 3 over 4, power on power. Here, cube root of 64. Okay, well, cube root of 60, let's deal with the inside first. Cube root of 64 is a 4. And then v, 6 over 3. Hey, that's a 2, right? 6 over 3, that's a 2. The index, the root is the denominator. That's v squared. Well, when you square root 4 is a 2, square root of v2 is a v. Oh, that reduces to 2v. All right, finally, what do we do here? All right, the fourth here is same as having a fourth, right? That's the bracket, and then 3 over 2 is on the outside. Power on power, let's multiply them. x5, y3, power on power become 3, 8, right? You just multiply them. And finally, you just multiply to everything. Okay, x 15 over 8, y 9 over 8. You can't reduce anything. That's the answer. Okay, so that's it for this chapter. Okay, so you can try the homework just to familiar yourself with all these different expression. Should I do one question? Maybe I'll find a difficult one near the end here. Let's say question. Now this is a good one, right? Do the matching. They all look very similar, but they mean different thing. So maybe I'll just do one more. 7f. Okay, 7f. What do we do here? 7f. So fourth root. And then 3 over 2. This is power and power. You can just multiply everything. The other example we saw, we multiplied the 2, 1 on the outside first. This one we can multiply the inside first, because when you multiply things together, the order doesn't matter. So 4 times 1/4 is just 1, so that's x. And y, you have 3/4, and then you have that. Now you multiply to each one, so the final answer, 3/4 y 9 over 8. Okay, so that's it. Bye.